So we're gonna talk about the Simpson rule today. So Simpson rule is in the numerical integration, which I believe is more precise than the trapezoid or like midpoint rule. So when you try to memorize equation or formula here, what's the easiest way to learn is that you put it one time and then you will kind of have the feeling why this formula is look like this instead of like force yourself to memorize. And also sometimes like during the exam you might forget the formula. But if you have the concept, you can try to prove it step by step instead of like lost the points because you just forget about the formula. So let's go into prove the Simpson rule today. Okay, so Simpson rule. Let's draw a picture here. Okay. Here is let's assume here is your even function. F of x equals to your a times x to the power of 2 plus b times x plus c. And you want to know the area value from minus alpha to alpha. Okay, so as we all learn the integration, this will be looking like here. Will be looking like this. Integration from minus alpha to alpha of a times x to the power of 2 plus b times x plus c with respect to x. This means the area value from minus alpha to alpha. So let's just separate it here. So integration from minus alpha to alpha of a times x to the power of 2 with respect to x plus integration minus alpha to alpha of b times x with respect to x plus integration from minus alpha to alpha c with respect to x. So as you can see here, your first one will be from it's like 2 times 0 to alpha is square with respect to x plus, so this one here will cancel it out. Why? Because it will be bx to the power of 2 divided by 2, and then you plug in the from minus alpha to alpha, which will be 0, and then plus integration from 0 to alpha, 2 times here, and then c of c with respect to x, which will be look like 2 times x to the power of 3 divided by 3. Okay, and then from 0 to alpha plus 2c to c times x, and then from 0 to alpha, which will be 2 over 3 times alpha to the power of 3 plus 2 times c times alpha. Okay, so here is the integration part. This is the outcome. Let's see how we can make it relate here. So let's assume your f of minus alpha will be your y sub 0, which will be, okay, let me see. I think I should use different layer. Okay, and the different colors as well. So your f of minus alpha, let's assume this is your y, okay, your y0, your y1, your y2, which will be a times alpha to the power of 2 plus b alpha plus c. So your y sub 1 will be f of 0, which will be c. Okay. So your y2 will be your f of alpha, and then here is minus times alpha to the power of 2 plus b times alpha plus c. So how do we make this looks like the outcome here? Okay, let's shrink it a little bit. See, I don't need the arrow. I will just erase it. Okay, so to make them, okay, we'll use a different color. To make them similar look like this, then you will observe. Okay, so if we use y0 plus y2, then your b times alpha will disappear, right? Which will be a to a times alpha to the power of 2 plus 2c. So let's do it one by one. So I think I need to use a different color. Sorry, let me write it down one more time. Okay, so because you want to make these look like the things here, let's say use the first part, and this one is your second part. So for the first part, you can try to add y0 plus y2, which will be look like 2 times a times alpha to the power of 2 plus 2c, right? But this one is too much, so we can write it down like y sub 0 plus y sub 2 minus 2y1, which is 2c. And this will be your first part, which is 2 times alpha to the power of 2. And because here is to the power of 2, then let's just let it times alpha, okay? Times alpha. So this will be exactly the same like your first value. So, okay, so the second one will be, color is different. Okay, the second one, okay. I think I accidentally erased alpha. Maybe this number, this color, okay. It's different, sorry. So, okay, so the second part, your 2 times c alpha will be your y1, 2y1, sorry, actually 2y1 plus, okay, I will use different color for times alpha. So you added your 1 and the 2, which will be your alpha, y0, y sub 0 plus y2 minus 2 times 1, y sub 1, and then plus your alpha times 2 times your y sub 1, which, if you make it more clean, will be alpha. Oh, actually, sorry, here is all over 3, right? So, yeah, don't forget here. Okay. So let's factor out the alpha over 3 here. So here will be your y0 plus y2 minus 2 y sub 1. Here, because you take 3 out, so here will be your plus 6 y sub 1, which will be alpha 3 y0 plus 4 y1 plus your y2. Okay? Oh, okay, I'll move to here better. Here is your 1. Okay, so as you observe here, your alpha, not this one. Okay, let's use this one. Your alpha will be your, let's say this one is A, this one is B. So your alpha is B minus A, and then divided by 2, right? Which 2 is like here, 1 and 2. So will be your N. And then here, don't forget the 3. I will use different color. Maybe this 3. Okay, so here will be the same. Your y0 sub 0 plus 4y, 4 times y sub 1. But be careful, because your function is not only looking like one part only, it will be like a lot of them, which will be, let's say from here, y0, y1, and then y2, y3, y4, all the way to y sub n. Okay, so here will be, your coefficient will be 1, 4, 1, and then, because 3 together, right, your parabola. And then the next one will be also 1, 4, 1, so forth and so on. So here will be, the total coefficient will be 1, 4, 2, and then 4, 2, so forth and so on until 2, 4, and then 1. Okay, so let's get back here. Because you all know that, so here will be 2 times, I think the color is different, plus, why is that? I think I drew it too light. Okay, probably that's why. Plus 2 times y sub 2, and then plus 4 times y sub 3, so forth and so on, all the way to 4y sub n minus 1 plus 1y sub n. So therefore, this is the formula for the Simpson rule. Okay, so when next time, if you forgot about the Simpson rule, the formula, then you can try to use this method to get the formula back.